There it goes. All right. Well, hey, welcome everybody. Welcome again to Astronomy Daily Live. It's 2 hours UTC, and it's time again to gather together this group of friends, ever-growing group of friends, and just sit back and talk all things astronomy for about an hour or so each and every day. We try to do this each and every day. Sometimes that doesn't happen, but I definitely try. And I think for the most part, I think we're doing pretty well with that. So yeah, so hope everybody's doing well out there. So grab your consumable of choice. I've got the HOH here, the hydrogen hydroxide. It's a amazing chemical here, and I don't know. I think there's, I should actually work this out a little bit more, right? According to the chemists out there, one mole of anything contains about 6 times 10 to the 23 molecules of that thing. So that's a lot of molecules. And one mole, the easiest way to do that, to figure out how much that is to take the atomic weight of your molecule and call that the number of grams, right? So with HOH, right? Let's see, oxygen is, I think oxygen is 16. It has an atomic weight of 16. And it has 2 hydrogens, so that's an atomic weight of 1, approximately, right? So 16 plus 2 is 18, right? So 18 grams of HOH would be 1 mole of that, and there's something like 6 times 10 to the 23rd molecules. It's Avogadro's number. So 18 grams is something like about a third of an ounce, maybe half an ounce, about half an ounce or so. So, I don't know how much is in this. I think this is supposed to be 32 ounces. Is that right? 32 ounces is a quart, something like that. Is that right? I think so. So yeah. Anyway, there's a lot of stuff in this little tiny mug, right? There are billions upon billions upon billions upon billions of molecules in just this little tiny mug. So it always amazes me how much stuff there actually is in a pretty small volume here. So you might hear sort of in the background like these falling rocks and stuff. That is one of the kitties doing his job. Okay, here it goes again. Here goes the last one. I've got a bunch of rocks on a shelf over here, and I put them up on the shelf. And he sits there and just knocks them all over, just one at a time. So he is definitely doing his job really, really well. And he's looking at them all now, going, "How did that happen?" And he's actually looking for more, but there aren't any more. They're all on the ground now. So that's actually one of the things that is an argument against the flat Earth, right? Is that if the Earth were actually flat, the cats would have knocked everything off by now. So given the fact that things are still here, I just can't believe it's flat. Anyway, hey, we have a new panelist. That must be Patrick Manny. Hey there, Patrick.
Hello. Can you hear me?
Hey.
Can you hear me?
Yeah.
Oh, okay.
We we can see and hear you very, very well. So welcome, welcome. That was pretty easy, huh?
Yeah, it wasn't too bad.
Cool. Nice. All right. Well, welcome. Excellent, excellent, excellent. Also on the panel, back again, is Bobby. Hey, Bobby.
What's up? Hey, Patrick, how you been?
Hey, Bobby. Good seeing you.
Oh, yeah.
Very, very cool.
That's neat.
Yeah,
My picture looks bigger than the others. I don't understand that. Down at the bottom.
Yeah, I don't know. You know, this technology baffles me. So, you know, I just push buttons too. So, I don't know.
Maybe I have to 40 by 480, something like that. I don't know.
Yeah. And we've got Tom over here too. Hey there, Tom.
Hey, Cosmic. Hey, everybody. Hope all is well. Patrick, when I look at the bottom of my screen, it shows me that mine is bigger than all the rest. So that's probably the way it works. Yeah.
Oh, okay.
You're just sort of
I'd like to welcome Crystal Gems in the chat.
Oh, okay. Yeah. You know what? I need to pull up the chat here. Hey there, Crystal Gems. Haven't seen you in a little while, so welcome back. Nice to see you there. Nice to see you there. So yeah, I think we're actually going to be getting some snow here tonight. So, you know, but
and I got some storms all throughout the rest of the week, and then probably throughout next week as well.
Oh my gosh, yeah. And we're supposed to get into the teens Friday night. Tomorrow night. Actually early Saturday morning, it's supposed to be in the teens. So here that's really, really cold. But you know, 1 or 2 nights a year gets that cold. No problem at all. So yeah, it's actually also going to be clear.
Nightbot just got Crystal Gems.
Oh, Nightbot is just is so incredibly judgmental. So Crystal, please excuse the Nightbot. I'm trying to train that little guy, but he's a little stubborn and yeah. So hopefully, you know, don't be turned off by that. Nightbot is sort of doing his job. As I said, yeah. I still don't know if Nightbot is incredibly useful or not. So, you know, but I got to give him a chance. And once in a while, you know, too many emotes or too many caps or anything like that sets Nightbot off. So, you know, maybe you can do something, you know, to get into Nightbot's good side by just asking Nightbot about your local weather. So if you do a my weather command and then like a zip code or the name of a city, you can get a little weather report there. So there you go. There's mine. So yeah, all right. Well, cool. Hope everybody's doing well out there. Now tomorrow night here, it's supposed to be clear. Hey there, ERRT Radio. How you doing, Ron? Hope everything's well. So tomorrow night here is supposed to be clear, and there's also not going to be any moon out. So I think I'm going to probably have to be out with the scope tomorrow night. But I don't have any real timeline or anything except that I have to take my calibration data at sunset. And sunset these days is taking place actually pretty early, about 5 o'clock p.m. local time. So yeah, I should be able to take my cows and still do the live stream and everything. And then right after the live stream, I can head out and do what I've got to do. So I don't think at this point that I'm going to have to cancel the live stream or anything, but you never know. So yeah, sort of keep your ears peeled. I will definitely try, to make an announcement as early as I possibly can. But right now, I'd say that there's a 99% chance that the live stream will happen. So there's always a small chance that it's like, but yeah, I don't anticipate anything stopping me from doing that, because this is fun and this is important, and I like doing it. So I don't want to have to skip things unless I really have to. And yeah, I'll lose an hour or two of dark sky. That's all right. I don't, that's actually just less time. That's less time that I'm going to have to be out in sub-zero Celsius temperatures out there. The humidity is going to be a little bit high too. So maybe it's not going to work out at all. We'll see. But I'm still doing this project, trying to characterize how well this telescope works, and my confidence is relatively high, but with some more observations, that confidence is just going to get higher and higher and higher, and that's what I want. That's what I want. So confidence must be high. Hey there, Uncle Bill. Nice to see ya. Yeah, I think, Uncle Bill, I sent the emojis. I'd have to look, but I think I sent them to like 10 or 15 or something like that. So don't know. All right, well, cool. What I thought that I would do today is wait for Kitty to jump in my lap. Come on, here we go. Can't really see her that well, and she doesn't look too happy there. So there you go.
Hey, kitty.
Hello, dear. She'll settle down. She's going to give herself a bath. That's what this particular one does almost constantly, is just bathe. And, I'm sort of the bathtub, so that's all right. Yeah, so what I thought that we could do is sort of get back to the constellation of the day that we picked. Oh, it's been a while. And sort of wrap that up, sort of get that done. That was the constellation of Corvus, which is just a little tiny constellation that you can actually see in the morning sky right now. It's basically just four stars in sort of a rectangular shape, but like with everything else, there's just tons and tons of stuff, even in that little constellation. So I just like to go through it and see what else. And I've actually got things moderately a little bit more organized, such that my Burnhams is right within arm's reach. It's not way down there anymore. So that's a major step up in terms of organization. And I think this was the one. By the way, you see this here? Okay. This little one here is the guilty party. This one. Yeah. You like doing that, huh? Yeah. So she's in major trouble. But Oh, that's how it goes, you know. All right, so let's grab. Oh, I'm hearing somebody's phone.
Yeah, it's mine.
Oh, okay.
Guess it's going to be a short first visit.
Oh, all
I
right.
got a phone
All right.
call coming in, so how do you
Okay, well,
how do you leave this thing?
yeah, I think you might just have to X a window out. I'm not exactly sure. I've never done it.
At the top of the Google Hangout window, there's a little phone icon.
Oh, I see it. Yeah.
Yeah, that'll
Red
hang.
call. Yeah, red.
Yep.
Yeah, leave call. Yeah.
Yep.
All right.
Yeah.
See you guys later. Sorry about that.
All right, Patrick. We will see you next time. You know, come in any single time. I'll send you an email every single day now. So you know, feel free to come in anytime you want. You are you know, more than welcome to come in. Yeah, I think that'd be great.
All right. Take care, guys.
All right. Take
Bye.
care, man.
Bye.
See ya.
Bye, Patrick.
Bye.
All right, so let's see what Burnham's has to say. I don't think that Burnham's is gonna do much more. Yeah, just talking about sort of the four main stars, the four bright ones, and then the ringtail galaxy. I think, you know, I think the ringtail is also called the antenna galaxy. I think it's got a couple of different names. That's like NGC 4038. So we sort of looked at all that already. So yeah, I'm not really seeing anything else in Burnham's. You know, they do list a bunch of galaxies, right? Just a whole bunch here. In fact, they even show off a globular cluster. I wonder if we should look at that one. That's NGC 4361. There's a couple galaxies over here, too. Oh, it's hard to see. So, yeah, you know what? This that's kind of an interesting place for a globular cluster, right? Most globular clusters are sort of centered around the center of the galaxy, you know, the galactic bulge of the Milky Way. Sometimes they call that the galactic halo. And it's, I think it's at least hundreds, maybe even more of these globular clusters that are just sort of right around, you know, the bulge of the Milky Way. So to have a globular cluster really that far away from the Milky Way bulge is a little unusual. And I'm totally into unusual things. So why don't we take a look at this? NGC 4361. All right, so I'm going to, let me pull up Simbad here. Let's go over to Simbad. Are you comfortable yet? Huh? You keep wiggling around and stuff. Yeah. I don't think that you're getting very comfortable. I don't know. I'm just the servant around here, so I just have
I'm getting
to.
thunderstorms in the area, so I just had to disconnect my radio.
Bummer. Bummer. Okay, so I'm going to go over to Simbad, and then I'll share my screen here. No, that is not for you. Okay, all right, I'm ready to share my screen. Dun, 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 dun. Have to reach over the kitty to be able to do this. Really have to accommodate you, don't I? All right, sharing my screen, going to infinity. I wonder how far that goes back. I don't know. Pretty far. Whoop, let me hide this. Sorry. Over to Simbad. And of course, all right, so we're looking for NGC 4361. And this is in the constellation of Corvus. We'll get some celestial coordinates here. Oh, planetary nebula. Oh, man, I totally misread that. Shoot, I thought that was a globular cluster. No, it's a planetary nebula. Okay, that's not so unusual anymore. Okay. Still, let's take a look at this bad boy. So, right ascension in the sky, 12 hours, 24 minutes, 30 seconds, and then a declination of negative 18 degrees, 47 minutes and 5 seconds. Proper motion, pretty small. Radial velocity looks like it's moving, I think that's towards us at about 10 kilometers per second, which relatively speaking isn't fast, but 10 kilometers per second, let's see, that's moving pretty darn fast. Pretty small, 1.35 arc minutes on a side. Looks like it's pretty round. Most planetary nebulae are relatively round, or at least sort of symmetric. These are sort of one of the end states of a star. They say that our sun is eventually going to look like a planetary nebula with a like a white dwarf star right in the middle, and then this envelope of gas and dust sort of blowing out and expanding out to form a some kind of a round structure, but very, very, very faint. Wow, 13th magnitude. Yeah, you need a pretty big scope to see this, because it's really, really faint and really, really small. I'm gonna zoom in a little bit. I think that helps everybody sort of see things a little bit better. Now, look, are you gonna sit here or are you gonna cause trouble? All right, but you have to move. You cannot you cannot stand in front of the screen, because then I can't see anything. All right, I have to move the immovable object. There we go. I can do that. All right, so there's a bunch of different names, like we normally expect. Don't see anything too outstanding here. Just sort of your normal catalogs and whatnot. Gaia, Data Release 2 has identified it. IRAS was I don't think IRAS is operational anymore. It was a infrared satellite. I think back in the 90s, I think so. EUVE was also a satellite. I think also back in the 90s. IRAS was looking in the infrared. EUVE was looking in the ultraviolet. So, yeah, same object, bunch of different names. Wow, so pretty well studied. Wow, 379 references, supposedly. So that's pretty interesting, pretty exciting. It seems as though we might know a little bit about this object. That's kind of cool. Got some distance measurements here. Let's take a look here. So, yeah, relatively good agreement. It's, a couple of hundred parsecs difference there, but let's sort of take the average of that, right? It's something like 900 parsecs. So a parsec, of course, is 3.26 light years. Let's multiply that by 900 light years per parsec. So you get 2,934 light years away. So that's not incredibly far. It's not really close either. So pretty good agreement here, right? They made a measurement in 1953 and again in 1995, and they got the same number. hey, that's pretty awesome. Doesn't happen all that often. Let's see, parallax. I'm not quite sure what MK is. Yeah, I guess we'd have to look that up to really know. But wow, that's a reference that goes all the way back to 1920. Here's some observations and stuff. But yeah, let's not get into that too much. I guess let's take a quick look at the references. There's way too many to go through them all, so I am definitely not going to. One of the things that I like to do from time to time is look at like the first one, the first reference to this object, 1918. Publications of the Lick Observatory, the planetary nebulae. Let's see if that's available to actually view here. It'd be kind of cool if it is. 1918, that's 100 years old. No abstract, but oh, look. And I think at the time, I think the Lick Observatory was one of the largest ones, if not the largest one. By Heber Doust Curtis, astronomer in the Lick Observatory. Very cool. I like these old books and stuff. Carried out on Mount Hamilton during the past 3 years. A considerable proportion of the time available for using the Crossley refractor has been devoted to securing a series of photographs of all the planetary nebulae north of 34 degrees south declination. So that's probably pretty much everything that they can see, right? Because they're in the north, and that's pretty far south. So let's see. So here's sort of a pixel scale, right? One inch on the negative equals almost 1,000 arc seconds. So 30 arc seconds is 3/100ths of an inch. And of course, they can enlarge that. So yeah, they can actually get and still to this day, you can actually get better resolution with a photographic plate, with actual photograph than you can with a CCD, because the CCD camera, the pixels, small pixels are like 6 microns, but they're really noisy, right? So most CCDs this day, as far as I know, are like 9 microns or 13 microns or bigger. And I believe the size of a grain in a photographic emulsion is less than a micron, I think. But what you lose, I think, is sensitivity. So photographic emulsion, I don't think that you'd be able to see as faint objects given the same exposure time. So, there's always a balance. We're talking about balance earlier. Here's a balance. So, you want resolution, or do you want sensitivity to faint stuff? So, anyway, let's take a look at a few of these. This would probably be a really, really cool read too. So here's some shots here. I guess they're saying exposures 20 seconds to 2 hours. I guess this is probably a 2-hour one, and this is a 20-second one, I would think. Maybe not. Here's some 2 hours 40 minutes exposure time of NGC 246. Okay, so yeah, they're just going to start going through them all here, it looks like. So what was our guy? It was, I don't remember now. We're going to find out. 4361. Let's see if we can find him. 4361. Uh-oh. I don't think it's finding it. Looks like this is in numerical order, so maybe we can just sort of go down here, because, yeah, it's not, I'm not finding that number, at least. 4361. These are, well, you know, for the time, these were probably really, really great photographs, but I gotta say, not too great. Now, the tracking is really good, right? We got nice round stars and everything, but yeah, that's kind of yucky looking. Still, it's kind of neat to see these things. It'd be interesting to compare, you know, images taken then with what they look like now, and see how they've changed. Because over the course of 100 years, I would think for the most part you'd be able to see. I think the changes would be pretty obvious, I would think. Okay, well, they're running out of NGCs here, so I'm not quite sure what they're going to do at the end here. Of course, there's, what, 7,840 NGC objects, and we're already up to 6620, and we're not even halfway through, so I don't know what's up with that. Let's see. Oh, okay. Yeah, you see here, they're wrapping around, so, But, and maybe, oh, I see what's happening. These, you know, this paper isn't really actually even text, right? It's just like an image that has been placed into a PDF file. So, ooh, yeah, being able to find these is going to be tricky, unless we can find a pattern. And I'm not quite sure what the pattern is going to be. I thought that they were going to be in some kind of numerical order according to NGC number, but I don't think that's the case. Hearing quite a bit of echo, Bobby. Just FYI. Sorry. Let's see, 6818. Yeah. Yeah, I would. We'd have to go through these one by one, and I don't know if I want to take that kind of time to do that. So my guess is that it's probably in here, right? It's just it's just a matter of finding it. And like I said, I don't think I'm gonna take the time to do that, which is too bad because I sort of wanted to see it. Maybe I'll be no, I don't want to be that stubborn. Some of these are some pretty good shots, I guess. Let's see what's at the end. Here's more words. Okay, here's sort of a distribution. That's very cool. Planetary forms. While the details of the forms assumed by individual planetaries are frequently of bewildering complexity, there are certain characteristics which are common to many members of the group. Central star, yeah. Very cool. Yeah, I'll bet you that this is a really, really interesting read. Maybe I can, why don't I post this over in the chat, and if anybody wants to grab it, you can, just like that. Cool. All right, well, Crystal is still with us. Andy, hey there, Andy, nice to see you also over in the chat. We're looking at an old paper showing off some planetary nebulae. So yeah, I'll bet you this is a really, really cool read. You know, if you're into the history of astronomy and the history of science, this is where to go for sure. Okay, well, like I said, I don't think I'm going to linger on this too much, because that's a little too much effort for what I want to go through here. So let's just sort of look at the more recent ones. It's kind of nice, you know, they list these in chronological order. That makes it nice. But this particular object has been studied really, really, really well. I'm sort of tempted to go over to HST and see if HST has looked at this. But it looks sort of just like the common stuff, right? They're looking at the nebula itself and the central star in X-ray. I think I saw up here like hydrogen alpha. So yeah, just, you know, taking a good look at it. One of the other things to sort of notice is that, you know, sometimes the same author will appear, you know, studying, you know, the same object, right? You know, they have a particular interest in either, you know, one object or one aspect of an object, and so they will just, you know, study it to death over the course of years. Sometimes a search for magnetic fields on central stars. Cool. Yeah, yeah, like this, right? He's got one here. This Martinez Gonzalez, right, did an AppJ thing talking about magnetic fields, you know, the upper limits to those fields. And then in the very next paper, in a journal called, I think that's Astronomy and Astrophysics. Looks like, you know, he participated in the writing of something very, very similar. A new quadrupolar planetary nebula. A quadrupolar? Oh, I don't think I've ever heard of that. That's kind of interesting. Now, you know, why is this paper referenced to our object here? I don't know. Let's find out. I'm kind of interested in seeing what this looks like, though, too. Yeah, let's take a look here. Oh, I'm already seeing some pictures, but I'm not going to spoil it too much. Shoot, now, I always never remember what our actual object is. 4361. Okay, so let's look for that first. All right, that's only fair. Aha. So let's see. I'm going to go back, see if I can find the beginning of the sentence. originally this subclass included, and this is just a list of objects. So since then, the sample of, too big, of quadrupolar planetary nebulae has increased with time up to 10. But there are certainly more because planetary nebulae are prone to be classified as quadrupolar, like NGC 4361. Cool. Okay. So apparently NGC 4361 is a quadrupolar planetary nebula. Huh. I don't know much about these. I don't know if I've ever really heard of a quadrupole planetary nebula. I wonder if we can get like a basic definition. Okay. Some position velocity maps. Okay, so these aren't images. these are looking at things in a different way. Turn my music back here. There we go. Okay, so that's not an actual image. Schematic lobes, different morphological components labeled on it. Okay. So I guess that's sort of what I was looking for, was sort of the structure and everything else. So there's a central star, and then you've got these lobes and you got these rings. Huh, okay. Kind of cool. I wonder if we can get a shot of, okay, so this is this particular object, KN26. And yeah, kind of interesting. So I like this, how they labeled this, right? O3 is the blue stuff, oxygen 3, nitrogen 2 is green, and hydrogen 2 is red. So you can kind of get an idea as to where the stuff is. Kind of interesting, right? That there's all this red stuff here, and this is yellow, which is, I don't know, is that is blue and green? Does that make yellow? I think so. So it seems to be along this edge, there's hydrogen, and along this edge there's sort of nitrogen and oxygen. Kind of interesting. Cool. What's this up here? Okay, so these are just different wavelengths again. Not really seeing a lot of, wow, is that, I'm not quite sure what BR gamma is. Not quite sure what that is. So here's O3, N2, and hydrogen alpha in green. So, yeah, sometimes it's hard to understand all these things, but that's why I like to look at it. Okay, well, enough of that. Let's take a look at this over here. So that's pretty overexposed. Can't really see a lot of details in the middle there. Pretty interesting structure around it, though. Pretty complicated. Hard to know, I guess, if this is like a quadrupole or not. I guess, you know, there's a couple of things here, but yeah, it's kind of hard to tell. Just going to zoom out really quick, see if there's anything else interesting around it. Nice color. There's a little galaxy up here. See if there's anything else. And actually, as far as planetary nebulae go, this is a little bit on the bigger side. What was it? Like 1 1/3 arc minutes. That makes it, what, about 90 arc seconds across? That's pretty big as far as planetaries go. But yeah, wow. And sort of the surrounding area, not seeing much more than just foreground and probably background stars. Because I think this guy was pretty close, right? Didn't we decide that it's about 3,000 light years away? So yeah, that's actually pretty close. I would think that a lot of these stars might not be all behind it, but I would think that quite a few of these stars would actually be behind it, further away, you know. Well, cool. Let's see if HST has anything to say about this. 4361. I'm just going to steal that. Punch it in right there. And we'll just look for everything, huh? Since it had so many papers, yeah, okay. It has been observed a little bit, not too many rows here, but a few. And they're talking about, this is actually the name of a star. I wonder if that's the central star, HD 107969. I don't know. I don't know if Sinbad had anything to say about that or not. Probably not. Oh, yeah, there it is. Oh. So let's see. STIS, which I never remember what that stands for. I don't remember if that's a spectrograph or if that's an image, but we'll take a look anyway. I'm thinking that's a spectrum. That's sort of what a raw spectrum looks like. Yeah, those things are messy. A little overexposed too, kind of hard to tell what's going on there. Let's see, let's take a look at another one. They took a number of these, it looks like. So that's sort of the same thing. Okay, so this is all STIS. Let's go down here, 1996. It's a little far off, but they actually looked at it with PIC 2, which of course is the fixed optics. And a pretty short exposure, so yeah, not really seeing much. Maybe a little bit of a halo here. That's my guess is, at least, that is probably the central star. But yeah, that kind of an exposure, 26 seconds, not seeing very much. Here's one that's a little bit longer. I'm getting major echo from you, Bobby.
Yeah, for some whatever reason, I got disengaged from my Bluetooth speaker.
Too many buttons, that's all.
Yeah.
So yeah, there's, you know, it looks like they're sort of seeing a little bit of nebulosity around here. And I guess that's probably the central star. But yeah, I'm not too impressed with that. And I think STIS, let's just look at a couple more of these. But it's probably a spectrum again. Yeah, okay. So, yeah, nothing really too exciting here. Let's just, you know, let's go to good old Google and see what it has to say. What is it? 4361. 4361. Let's just see what this has to show, if anything. Yeah, pretty nice.
So wait, radio doesn't have all that information and stuff.
What's that, Bobby?
Doesn't look like Wikipedia's got all the information about that galaxy.
Yeah, it's got a little bit. We can plug into this, and of course, this is a planetary nebula, not a galaxy. But there's a galaxy up there. Kind of nice, though. You know, obviously, either taken with a color camera, or taken with a bunch of filters and colored later. But yeah, that's a pretty bright central star, and I don't know if you can see it here. I can zoom in a little bit, maybe. You can see that there are other little stars that seem to be inside of it. My guess is that those are foreground stars. Being what, 3,000 light years away, there's probably stars in between there. So that's probably what these guys are. That's a pretty good shot, though. All right, let's go back here and see. Okay. Yeah, there's not very much info about it. It's a planetary nebula in Corvus. Yeah. So, yeah, I guess not a lot of info there. The HST images are pretty crummy, but apparently very well studied. So, for whatever reason, looking at it in the X-ray, H-alpha, kinematics, which is just, how it's behaving, how it moves, how it does what it does. The enigmatic central star of PRTM1. These crazy names. I like them. Okay, well, we're not going to go through all of this for sure. So I'm wondering, I'm going to grab, let's go to, bad typing day, Corvus Constellation, and see if Wikipedia has anything else to say about this. I don't necessarily like to rely on Wikipedia to, tell me too many things, but it's a nice jumping off point. Spectroscopic binary, VV, Corvi. It's kind of cool. Yeah, there's always more than what we want. So Ross 695 is a red dwarf star, pretty close to us. Magnitude 11.27. So yeah, can't see it without a little bit of help. Yeah, so they're just listing a few other stars in there. 4027. There's 4361 that we just looked at. Cool. Okay. Well, not seeing much else with Corvus. I mean, it is a pretty small constellation, so can't expect it to have too many interesting objects in it. But when you see this in the sky, it's really, really obvious, right? I mean, it looks like a trapezium, or sort of a weird looking, not a trapezium, a trapezoid, or sort of a weird looking rectangle, right? Pretty easy to see because there really aren't a lot of bright stars around it. I think this is Spica up here. I think this might be Spica. I think so. Yeah. So relatively close to Spica. Pretty easy to see. Pretty easy to pick out because there just aren't a lot of brighter stars around there. So yeah, and I think right now Corvus is up in the morning. So if you're a morning person, you can poke your head out and see if you can see that guy. Yeah, nice. I think actually this red galaxy up here, I think that's M104. I want to say that it is. It's not actually in the constellation, so it's not going to be listed, but we've got a chart right there. Let's just look at the coordinates and see. So M104 is of course also called the Sombrero Galaxy. So it's about 1240 and negative about 11.5. So 1240, 1220, 1240, and negative 11.5. Yeah, I think that is this guy here is Messier 104 right there. So yeah, just if you're a star hopper, got to find Corvus first, and then you just sort of jump off Corvus to find that. So cool. All right. Well, I'm looking at the clock, and we're coming up to the hour. What do you think? Should I cut this a little bit short tonight, since we're sort of at a stopping point? What do you think? Is there anything else on anybody's mind? I'm going to look in the chat.
I got nothing.
There's nothing in your mind at all, Bobby?
The what?
There's nothing in your mind at all?
It's like I said, I got nothing.
All right. Let's see. Yeah, I think this is a good stopping point, because I'm afraid that if I get started with something now, we're going to go for another 30 minutes. And, we could do that, but let's cut this off now. So cool. We're going to be, just a little bit over an hour, in fact, by the time I actually push the stop button here. So, all right. Well, very, very cool. I think that is going to close the book on Corvus. So we can now move on to the, billions and billions of other things that are out there. So yeah, Corvus, like all the other constellations, has a lot to offer, and we could spend at least several more days on this if we wanted to, but not going to. Let's move on. So, all right. Well, with that, I think it's about time to go. So I'm trying to think if there's anything else. Everybody's really getting excited about Ultima Thule, which I think is really, really great. I think it's really, really awesome, and you know, we should be extremely proud of ourselves, you know, that we're able to do this and stuff. But you know, it is just a big rock. But you know, it's going to be amazing. We're going to learn a lot, but it is just a big rock. You know, can you get really, really excited about a big, huge rock? I guess it depends on your perspective a little bit. It is pretty far out there. But yeah, that's going to be going on in the next couple of days. I guess they're continuing. I think it's full speed ahead. You know, the encounter itself is literally going to take seconds, right? It's just going to, and it's going to be gone. So you know, they're going to be flashing those cameras really, really, really fast. And I have not drunk enough of this again, so I'm going to do that really, really quick. Cheers.
Cosmic, did you see where Tony Darnell's going to have a 24-hour marathon starting New Year's Eve? Yeah,
I did. I think, well, you know, we astronomers, we're pretty crazy people. So, you know, we do some pretty, you know, some crazy things for, you know, for a good reason, right?
So and they got some interesting guests they're going to have on. So
yeah. And I think Christian Reddy is actually going to be at like the control room or whatever it is. So that is going to be very, very cool. Yeah, it's going to be very cool. I will definitely be tuning into that from time to time. I'm not going to be there the whole time. That's not for the faint of heart.
Yeah, I think you're right, Uncle Bill. I think the TMRO stream is going to be involved too.
Mm-hmm. Yeah, it's great. You know, cooperation is the way to go. You know, getting them all, you know, together, pooling resources, pooling knowledge like that. It's going to be pretty cool. It's going to be pretty awesome. You know, we're going to be all desperate for those, you know, little bits of data, you know, that we're going to be getting. You know, that little tiny trickle, right? One kilobit per second, right? It's going to be just painful. But I think, you know, they sort of have worked a lot of this out, that, you know, they're going to be getting, you know, some thumbnails down, so, you know, they'll be able to see something relatively quick. I'm interested, of course, you know, in you know, all the other data too, you know, because they're gonna, you know, they've got magnetometers and spectrometers, all that. So you know, they're going to have all their instruments turned on and flying really, really fast. So yeah, I'm really, really anxious to see that data. You know, the pictures are going to be really, really cool, but there's also going to be lots and lots of data. And again, right, I think it's going to take a couple years for all that data to come down. So yeah, it's going to be an interesting one, and to have a marathon like that, yeah, you know, takes a bunch of crazy astronomers, you know, to do that. So they're doing it right. They're doing it right. Hopefully they've got you know, lots of either coffee or some other kind of stimulation. I don't know what they use. You know, keep themselves up. At the end, they're probably all going to be pretty frazzled, though. So, and maybe it won't last. Who knows? You know, but I think it probably will. they'll do things in shifts or something like that. So, all right, well, cool. All right, well, I am definitely going to get out of here for now. So, it's always great to have you all in here. Panelists are absolutely fantastic. And I just, actually, there's a couple of reminders. Number one, most importantly, panelists, feel free to cut me off and speak up, whenever you want, because what I'm going to do is I'm just going to sort of keep rambling, right? Because it's astronomy, it's science, it's space. So I'm just going to keep going and going and going. Cut me off if you want. I have no problem with that whatsoever. We're sitting on a porch, we're having a conversation, and that's how those things go, right? Somebody talks and then somebody interrupts, and that is perfectly fine, no problem there whatsoever. Number two, if you'd like to be on the panel, send me an email, cosmiclettuce@gmail.com, and each and every day I will send you a link to this Hangout. And the one thing that I wanted to mention is that when I send that email out, nobody else actually sees that mailing address, right? So I try to keep things confidential, and so those kinds of things you don't necessarily want to publicize. So yeah, I definitely keep those private. So none of the panelists know what the other panelists' emails are, unless they want to share them, right? And then it's not up to me at all. So yeah, and I think growing the panel, I think that's definitely a direction I'd like to go here, because I think that'll make it a little bit more unique, and I hopefully won't have to talk as much. Like I say, I'm actually a really quiet dude. I say more words in this 1 hour than I do all day long, really. So I definitely like to listen and hear what participants are saying, and I definitely like to sit back and sip a little bit of this and just listen and look and watch and all of that. So yeah, growing the panel is definitely a direction that I'd like to take this live stream, because I know this for a fact. I am definitely not the only expert here. I just just so happened to host this, but all of you are totally amazing, and so definitely feel free to speak up. Cut me off, no worries. I just don't care about those kinds of things. So all right, well, with that, I'm definitely going to get out of here now. So have a great evening, a great day. If you're seeing this for the first time and you like it, make sure to subscribe. You can hit the thumbs up or the thumbs down, make some comments, and spread the word. Spread the word. I'm trying to share my passion for the science of astronomy, science in general, space, all kinds of nerdy things, computer stuff, radio stuff, all the nerdy stuff. The nerds rule the world. Some people think they do, but no, it's the nerds that are running the show here. So and that's us. So all right, you guys. Well, with that, I'm going to get out of here. I'm going to check the chat one more time really quick just to make sure that I'm not missing anything. Ron, nice to see you in the chat. And yeah, Ron is not a quiet dude. He is definitely an active chatter. So very, very cool. Very, very cool. All right, you guys, I'm going to get out of here. Take care, and I will see you in a little less than 23 hours from now. All right, take care. Bye.
There.